of inches. There are 12 inches in one foot. Okay.
Ow. Mhm.
Are you okay?
Yeah, I
All right.
myself.
And then there's this conversion between inches to centimeters. There are 2.54 centimeters in 1 inch. Again, that's one of those that you'll learn or be given. And then from here, you're going to have centimeters to meters or kilometers. Okay, so let's just go to meters. There are 100 centimeters in 1 meter. And then in a meter, there are 1,000 meters in 1 kilometer. All right.
A lot.
There's a lot there. Now, have I sent over the Desmos scientific calculator for you to
Not
look
the
at?
calculator, but you sent the graph.
Okay, so one of the reasons I really like this one, sorry about that. I don't know if that switched off the screen or not, is that you can enter it just the way I have here. So you can enter it.
Are you sharing the Desmos?
I am not. I'm not.
Oh,
I'm
okay.
gonna ask you to. I'm gonna type it in and ask you to try it along with me.
Okay.
So it's like 35 times, and then you make a fraction like you have here for the 5,280 over 1. Then you make another fraction of the 12 over 1, and so on here.
Oh, okay, I got it.
So I'll show you in a moment here. It's good. It's really important that you do this on your own. Like that's why I'm not just sharing it, because there needs to be a little mystery, a little bit of like, okay, well, how do I even do this?
Okay.
All right, so let me snip this in so you can see what I've done here. Tell me what you got when you're all done here.
Okay. With Desmos?
Yeah, give me it to like 1 decimal place.
Times. And then what is it? Okay. Times 12. Oh no, I messed up. 12 over 1. And then 2.54 over 1. And then 1
Yeah.
over 100, then one over
Yeah.
1,000.
Yes. Do you have that? Let me know when you got that.
Sorry. Then times. Okay, I got that.
Okay, what's your final answer there?
It's 56.32704.
Okay, so if I asked you to round to 1 decimal place, what would you tell me?
56.4, I think. No, 56.3 still.
So the 2 tells you that it does not go up. So you round up if it's 5, 6, 7, 8, 9, but if it's 0, 1, 2, 3, 4, it stays the same. So it'd be 56.3.
Got it.
Now, I don't know what kind of cars you're in, but most cars still have both the metric, which is underneath here, kilometers per hour, and then the US miles per hour on the outside. So we said about 35, or we did 35 miles per hour here. So let me draw a line here. So that's 35. Where does that kind of hit? Is that about 55 there on the metric?
I think so. Yeah.
Yeah,
57
roughly, right?
-ish.
Yeah. So right there is great. It's 56, whatever. It's right there. And so that's the rate. I mean, that's the extent of the rate conversions. Now, were you given any of these conversions in class?
Yes, we were.
Okay, so that's kind of important here is to know like, well, what conversion problems you are being asked to do. So let me do some other ones here. So let's just do some simple ones here that maybe you already know how to do, but at least we can get some idea here how to do this. So they want you to take seconds and convert it into days. All right. So in this case, you start with the given number. Okay. In this case, it's in seconds. You can write the word out if you want. What is the next kind of unit up from seconds? Like, what do we usually convert seconds into if there's a lot?
Minutes.
Minutes. Yes. You have to kind of know this path. It's like, all right, well, there's 60 seconds and 1 minute. Notice that whatever was on the top goes to the bottom. Okay.
Mhm.
So what's going to go next?
Then would it be 1 hour over 1 minute?
So yeah, minute
60 over
to
1
hours.
or
Yeah, and
okay,
you have to
okay.
decide, okay, it's either how many minutes are in an hour or how many hours are in a minute. And then hours to days. There are 24 hours in one day.
That makes
So go to your calculator there and go ahead and see if you can calculate this for us, please.
okay.
Did you use a calculator in class or were you doing this by hand?
We do these by hand, but I can figure it out.
Well, I would like you to use a calculator just because it's very time consuming and
Okay. So 565, is it 000? Yes, no, 900. 900 times, let's see, 1 over 60. 1. Oh, I can type. Didn't realize I could do that. Oh, no. Okay, there we go. And then 1 over 60 again, and then 1 over 24.
okay. What did you come up with?
I got 6.5 if we're rounding all the way up.
Okay, so 6.5 days. So notice the units cancel all along. Seconds cancel with seconds, minutes cancel with minutes, hours cancels with hours, leaving just days. Okay.
Mhm.
So that's good. Now this should kind of like be sort of erase some maybe a question here, which is like, well, how many seconds are in like, I don't know, a year? Like how many seconds are there? Well, there's a lot, right? Because there's a lot of seconds, and that's only 6.5 days. Let's do that. So let's start with 1 day. Or I'm sorry, let's start with, back that off here. Let's start with 365 days because we know that's in 1 year. And let's go backwards here. So in 1 day, how many hours are there?
24.
Okay. And then you can go to hours to minutes. How many hours are in a minute or how many minutes are in an hour?
60 minutes, 1 hour.
Good. And then similarly, you can go from minutes to seconds, 60 seconds and 1 minute. So go ahead and calculate that. It's gonna be a fairly large number.
Okay. Times 24 over 1, 24 over 1, 60 over 1. Okay. 24, 1. Oh, no. Times 60. No, I messed up. Times 60 over 1 times 60 over 1. Over 1. Oh, no. Over 1. Here, I need to count the zeros. 31. No.
31 million.
Oh, okay. 31,536,000.
Very good. Now, I'm not sure if you ever just tried to count, like even just counting up to like, I don't know, 500 actually is kind of like hard for people to do. Sometimes people think, oh my God, that's not that much time, but actually it's really hard to count up this high. You know, there's in 5 minutes, there's 300 seconds. So just to count to like 300 is a big deal. So this is actually a lot of time. It really is. Like, I mean, it's a year. It's a years take a year, right? But these are some of the conversions you might see. So let's take a look at the next thing here. So we got some similarity problems. We'll just look at the one of the ones they give you here. All right. So just transitioning topics here. So there's assume that these are similar, okay? And you sort of need to pair up, like the 3 goes to the 9, and if you're wondering why, it's because it falls between the right angle and then the double line there, and it's like, what's the multiplier? How do you go from 3 to 9? Well, you multiply by 3. Okay. And then you also need to see, well, does that work for the other one? Like, does that work to go from the 5 to the 15? Does that same multiplier work?
Yes.
It does. So then you know that it also works for this 4 becomes what?
12.
Okay. Very good. All right. So let me look for a couple of problems here for us to work on like this. Let me see if this is a good one here. All right. Yeah, let's try trying to see. This one is just state if they're similar. Sorry, I just gotta need to find some here that actually are. They always want to show if they're similar. Why can't they just tell you to find? Okay. Okay, here we go. This is what I was looking for. All right, so here is a new problem for you to look at. So the key to doing these problems is to figuring out which sides, like which ones go with which, okay? And when they're drawn in the same orientation, it's not a big deal. Like you can just literally look it up.
Okay. So
So like in this problem, the 10 goes to the 25.
okay, so
like how do you, it's like an equation, 10 times k equals 25.
okay, 2.5.
Right, so k is 2.5, that's your multiplier.
Okay.
So is it 6 times 2.5 or is it 8 times 2.5? And I might as well have you do both here. So I'd like you to find x and y for me, please.
Okay. 6 times 2.5 is 15.
Okay.
And
Good.
then 8 plus or times 2.5 is 20.
Good. All right, let me pull up another one here for you to do. So this one is not in the same orientation. So this is the harder one. This is the one where you got to sort of like decide, which goes with which. And if you're not sure, please ask. But I want you to find both x and, well, actually, you can't do that. You can't because we don't have that side. Okay, just find x in this problem.
Okay. Okay, x. Okay, that's going to be the inner part. So 20 goes into okay. Would x be 25?
So how did you get 25? Tell me.
So
I'm not saying you're wrong. I'm just asking. Like, what
since
did you do?
you're on the longer end of the triangle, Well, the x goes to the 50, but 20 goes into 42 times. So
So if you're going this direction, it's times 2.
yeah,
Okay, good.
and 50 divided by 2 is 25.
All right, I agree. Good. Okay, let's have you do another couple here. Let's see what else we got. Here's another one for you to look at.
Okay. Okay, so how many times does 15 go into 30? Oh, 2. So 34 divided by 2 is I need to figure that out. Oh, 17. Okay. So x, no, yeah, x would be 17
Okay, I agree.
and y, okay. Y would be 8.
That would be 8. Very good. All right, good job. Here, let me grab another. Let me grab another one here. So this one, the numbers just, let me see if you can actually do this one. And you're not generally not allowed to use a calculator.
Yeah.
Okay. Let's try one here. It's a word problem and see if it's kind of the same. It's kind of the same situation, but maybe you know how to do something like this. So a giraffe is 18 feet tall and casts a shadow of 12 feet. So it might be worth drawing that triangle. Okay, that's the giraffe triangle.
Mm-hmm.
And then there's another triangle over here for the person.
Okay. I draft it. I don't think I exactly. Oh, do I get it? Oh no, I get it. I get it. Okay. So cast a shadow of 4 feet. So 18 divided by 4 is 4, 8, 12, 16. Oh, you can't do that. Can you?
You can. So the shadow is 4 feet and we want the height here. And keep in mind, like Corey is a human, so he's not going to be
Okay. Oh, so okay, the unit multiplier is 3. So 18 divided by 3, that would have to be 6. H is 6.
it is 6. Good. Very good. Now you're supposed to have units, so 6 feet, right?
Oh, okay.
Which is important. You have to have the given units there. Otherwise, like, what is it? Okay, here's probably another one here. Some of these problems, it's almost like they're too easy. If they're whole numbers, they give you some that are these decimals, but this one I think works out okay. So try drawing the 2 triangles. Even it's a Ferris wheel, just draw, big triangle, little triangle, and label
Okay.
the appropriate sides there.
Okay. 20. How tall? 1.8 meters casts a 2.4 meter shadow. Okay. So unit multiplier is 5 and 1.8 times 5 is that's 45, 90, 90
Okay, so what is your multiplier to go
or
from
no, 9.
to go from 2.4 to 20?
2. I wrote 1.8.
Yeah, so you gotta be careful. You're looking for the height of
Okay. 2.4. Okay. Yeah, I wrote this all wrong. Okay. Okay. So 2.4. Okay. 20 divided by 2.4. Okay, there's that. Oh, you get a repetend.
let me check here. I'm sorry. I assumed that yeah, you do. Okay, so I've given you bad numbers. So I apologize for that. Let's just say let's just change this to 4 real quick, and then you can find the height. That'll work out.
Unit multiplier is 5, so 1.8 times 5 is, let's see. Oh, 9.
Yeah, because you're multiplying it times 5. Yeah.
So H equals 9 meters.
Which may not even make sense, but maybe it's a small Ferris wheel. All right, so that does take us to the end of our lesson for today. I know it goes quick.